Hey guys, welcome back. This is Physical Science Week 1, Day 4. And yesterday we talked about naming ionic compounds. Today we're going to be talking about writing the chemical formulas for those ionic compounds. It's going to be very similar slides because what we're doing is the same process as yesterday, but just backwards today. And we have the same. We have fundamental ionic compounds, and we have our exceptions of polyatomic ions and transition metals we need to consider. And remember, ionic compounds are when a metal and a nonmetal combine. And the way you find metals and nonmetals, a metal is to the left of the stair-step line, a nonmetal is to the right of the stair-step line. So the metals are the pink stuff, and the nonmetals are the blue stuff, and we're not going to worry about the green stuff. Let's just skip through this slide. Okay, so here's our steps. Step 1, you write down the ions of the elements including their charge. You determine the number of each ion it takes to make the compound with no charge. So let me give you an example. So you write down the ions of the elements including their charge. So that'd be like if we had sodium. Well, you look on the periodic table, sodium has an oxidation number of +1. So that's the ion with this charge. Or you'd have something like, let's not do chlorine. Let's do nitrogen, right? Nitrogen. You look on the periodic table, it has a -3 charge. If you look at your oxidation numbers that you write above at the top of the groups, you write the ions. Now, you determine the number each ion it takes to make the compound with no charge. So let's say I have my nitrogen with a -3 charge, and I have my sodium with a +1 charge. Is the charges balanced? No, they're not. Can I just change this charge to a +3? No, I cannot, because sodium has a +1 charge. So how can I possibly balance with these two molecules? Well, I would need more sodiums, right? If I have one more sodium, that's another +1 charge, and if I have a third sodium, that's another +1 charge. So now in total, I have um, a +3 charge and a -3 charge. That balances. So in order for this to be a compound, you would have to have 3 sodiums and 1 nitrogen. And this is the way we would do this. We're going to do this in a way that's called the crisscross method. I'm not going to explain it right now. You guys can probably assume based on what information I gave you it is, but we'll talk about it. And in step 3, you write down the chemical symbols with subscripts that balance the charges. And in step 4, you reduce and you simplify. So let's get into some example problems. That way we can do this. That way we can get through this material just quicker. Magnesium. You write down the ion. Step 1, you write down the ion, right? Mg, and then if you look on your oxidation number of the periodic table, it's a +2 charge. And I have phosphorus. Phosphorus, if you look on your periodic table, it has a -3 charge. Now, what the crisscross method is you take this number, not the charge, not the plus or minus, just the number, and you move it over here. And then you take this number and you crisscross it over here. And this is why it's called the crisscross method, because the arrows are crossing over each other, right? This 3 is going with the 3 from phosphorus is going over to magnesium, and the 2 from magnesium is going over to phosphorus. And the answer is going to look like this, Mg3P2. Now, you all want to double check your work, so let's double check it real quick. One magnesium has a +2 charge, but I have 3 magnesiums, so that's +2 times 3. One phosphorus has a -3 charge, but I have 2 phosphorus, so that's -3 times 2. And then you do the math to see if they cancel. So overall, magnesium gives me a +6 charge, and phosphorus gives me a -6 charge. This does balance. It does cancel, so this is a correct answer. I just double checked my work. Now, I'm going to go over the first example with you guys, and then you're going to practice. Aluminum, if I look at my periodic table, aluminum has a +3 charge. And then if I look at my periodic table, chlorine has a -1 charge. So I take the number, not the plus or minus, just the number, and I put it down here with chlorine. I take the number of chlorine, and I put it down here with aluminum, right? And then you'd write the chemical symbol, which is Al. How many, which is 1. You typically don't write 1, so we're going to not write it this time. And then the chemical symbol for chlorine with the 3 that it got from aluminum, AlCl3. And that is your answer. Now what I want you guys to do is go, ooh, that hides the, oh, that's pretty cool. Okay, now what I want you guys to do is go ahead and practice these next 4 practice problems, and then we'll go over the answers now. Okay, so the answers are lithium and nitrogen make Li3N because nitrogen has a -3 charge, lithium has a +1 charge. MgI2, because iodine has a -1 charge. Magnesium has a +2 charge. CaO, because oxygen and calcium. This one I do need to go over with you guys in writing. So calcium has a +2 charge. Oxygen has a -2 charge. So you do the crisscross method. The 2 goes down here with calcium and the 2 goes down here with oxygen. So you end up with Ca2O2. Right? But that's not my final answer, because if you look, the subscripts can actually be simplified. I can divide both of these by 2. And if you divide them by 2, you end up with this answer right here, Ca1O1. So you always want to do that last step of reducing. And then you have sodium and sulfur. Sodium has a +1 charge. Sodium has a -2 charge. You do the crisscross method and you get Na2S. Now, let's do more practice. Now, but instead of me giving you the names of the elements, I'm giving you the name of the chemical formula itself. So I'll do the first one with you guys. Beryllium, we know it has a chemical symbol of Be. And then nitrogen, it has a chemical symbol of N. I know it's nitrogen, it's not a polyatomic ion because it ends in IDE. It's not nitrate. It's not nitrite. It's nitride, IDE. So it's the element nitrogen. If you look at your periodic table, let's go back and check it out. If you look at your periodic table, beryllium, let's rewrite our oxidation numbers. Group 1A, okay. Group 1A has a +1 charge. Group 2A has a +2 charge. Group 3A has a +3 charge. Group 4A, Group 5A has a -3 charge. Group 6A has a -2 charge, and Group 7A has a -1 charge. Group 4A we can kind of ignore, but it will always have either a plus or a -4 charge, and that's why I don't talk about it too much, because it changes a lot and it's a little unpredictable. So, and it's only carbon. So that's when you get into organic chemistry, you'll talk about this group. Beryllium is in group 2A. All these elements have a charge of +2, so I know beryllium has a +2 charge. Nitrogen is in group 1, 2, 3, 4, 5A. 5A has a -3 charge. So now that I got all my charges, let's erase our oxidation numbers up here, and we'll move back to our slide, our practice slide. So beryllium, we do our crisscross method. The 2 goes down here with nitrogen, and the 3 goes down here with beryllium. So the correct answer is Be3N2. Sodium oxide, Na2O. Potassium phosphide is K3P. Aluminum nitride. There we go. Here's one I want to practice. Aluminum has a +3 charge. Nitrogen has a -3 charge. So you do your crisscross method. The 3 goes down here with aluminum, and this 3 goes down here with nitrogen. So you'll end up with Al3N3. But if you notice, that's not my final answer. The reason for that is because these numbers actually can be reduced. If you divide them both by 3, you'll end up with ALN. Ignore my writing there. This is your answer. ALN. And then the answer for magnesium chloride is MgCl2. Polyatomic ions. Now, when we're working with polyatomic ions, again, the subscripts for polyatomic ions cannot change. If you change this 3 to a 4, or you change this O to a 2, or you change this to a 4, what you're going to end up having is you're going to end up having different polyatomic ions. We don't change those subscripts. What you do change, if you want more of them, I'll show you over here to the right. Let's say I have this compound. How many sulfates do I have? Well, the answer is 1. I have 1 sulfate, because if you put it in parentheses, you'll see there's only 1 of these SO4s there. Now, how do I get more sulfates? How do I write that I have extra sulfates? Well, when you do that, you just put the 2 out here, right? You put it in parentheses that are written right here, and you write a little 2 here. And this tells me that I have 2 sulfates. So I'll give you one guess as to how many sulfates I have in this next molecule. And if you said 3, yep, you're correct. Correct answer is 3. I have 3 sulfates here. Notice in each of these, SO4, 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 I didn't change any of these subscripts. All I changed is the outside. because this number is what tells me how many of that polyatomic ion I have. So I want you guys to practice this with the polyatomic ions. I'm going to go ahead and do the first one with you guys. So sodium has a chemical symbol of Na and a charge of +1. Nitrate, it's not nitride, it's not nitrogen, it's nitrate. So we have to use this. Nitrate is, where to go? Oh, right here. Has a -1 charge, NO3 -1. So that's what you would write. You would write NO3 -1 charge. And then you follow your crisscross method. This one goes here, and this one goes here. So you'd write NaNO3. That's your correct answer. A few mistakes that I see. People confuse this for nitride, right? So then they try this, Na+1 and N. If you look on your periodic tables, nitrogen would have a -3 charge. They do their crisscross method, and then they write NaN3. If this was nitrogen, yes, that'd be correct. But this is not correct because I'm not asking for nitrogen. I'm asking for the polyatomic ion nitrate. Another mistake I see is people see sodium here, and they write Na+1, and they see nitrate, and they correctly recognize it as a polyatomic ion. So they write NO3 with a -1 charge. And then they follow the crisscross method. They put the 1 here and the 1 here, and they write Na, they don't write the 1, and they write NO4. This is incorrect because you're not adding this to the subscript. This is a mistake, right? That 1 doesn't go here. It goes outside of parentheses over here. So if you wanted to use parentheses, that's totally fine. Again, I'm okay with that because I want you guys to recognize that these are grouped together. They're stuck together like glue, and they don't change. You put the 1 out here, but you don't write the 1s. Now I want you guys to go ahead and, using that example, try the next 4. Pause the video, and I'm going to go over the answers now. So the correct answers are NaNO3, CaSO4, NH4, 2 with 1 oxygen, Mg3PO4, 2, and NH4NO3. And if you guys wanted, if you really want, it doesn't bother me, go ahead and use your parentheses around every single polyatomic ion. Even if there's only 1 of them, I will not mark you off. I mostly want to know that you know what a polyatomic ion is. All right, and then transition metals. If the metal is a transition metal, you need to identify the charge with the Roman numeral. We covered this yesterday, and the reason for that is because transition metals do change their charge. Pretty much this slide is the exact same from yesterday except for this bottom part. Copper +1, you'll write with a +1 with a Roman numeral 1. Copper +2, Roman numeral 2. So transition metals are actually easy when you go this direction because I'm giving you the Roman numeral right here in the charge. And something to remember is that the Roman numeral will always represent a positive charge because it's a metal, and metals always give away electrons forming a positive charge. That's why they're conductive. That's why we use them for electrical wire. All right, practice with transition metals. So silver, what's the charge of silver? I give it to you right here. It's +1. Chlorine, it says chloride, right? I know this is the negative charged chlorine. If I look at my periodic table, chlorine has a -1 charge. So I use my crisscross method, and you end up with Ag, 1, but you don't write 1, and then Cl for chlorine, 1, but you don't write 1. So here's your final answer. The next one I want to try is iron 3 bromide. Iron, I know, has a +3 charge because of the Roman numeral has a 3 in it. So iron +3. Bromide, that's the negative version of bromine. And if you look on your periodic table, bromine has a -1 charge. So you use your crisscross method. The bromine's going to get a 3 and the iron's going to get a 1, but you don't write your 1s. So the answer is FeBr3. And that's how you do it. So I want you guys to go ahead and get some practice with this. I will do the first one with you guys. Iron has a +3 charge. Chlorine has a -1 charge. We'll do our crisscross method, and you end up with FeCl3. Now we do this next one. Chromium has a +2 charge. I know that because of the Roman numerals. Oxygen has a -2 charge. I know that because of the periodic table of elements. I look at its group number, the oxidation for that group, and then you do the crisscross method. You end up with Cr2O2. Now, this is not my final answer because you can actually see that the subscripts do reduce. I can divide both of these by 2, so your final answer you would end up with is CRO. Now I want you guys to go ahead and practice 1, 2, 3, the next 3. And now that you're done, let's go over it. The correct answer is MN2O7, CRN, and AG2S1. Again, I made the same mistake as I made yesterday. I haven't fixed it yet, even though I should have. Subscript right here of a 1. And that's how you do it. Now, what I want you guys to do is practice these 3 examples and try to name them, right, yourself. I will give you a second to do it, to pause it and do it, and now let me go over it. So magnesium has a +2 charge. Chlorine has a -1 charge, so you end up with Mg1, you don't write the 1, Cl2. Ammonium sulfate, this one's super easy. You just look at the reference sheet. Ammonium, it's polyatomic ion. Phosphate is a polyatomic ion. Ammonium has, you have to know the charge. So ammonium has a charge of, there. Ammonium has a charge of +1. +1. And then phosphate has a charge of -3. There, ammonium. And then phosphate has a charge of -3. So +1, -3. We're going to follow our crisscross method. We'll write ammonium, which is NH4. Actually, instead of me writing it, let's just click through it. So the correct answer is NH43PO4, right? The ammonium gets the 3, and the phosphate gets the 1. Now, if you wanted to write this in parentheses, again, don't worry. I'm totally fine with that. Just don't write the 1 here because that's not necessary. All right, and then nickel 2 hydroxide. I know hydroxide has a -1 charge. This isn't hydrogen. This isn't oxygen. This is hydroxide, a polyatomic ion. Don't let this IDE fool you. It is an exception. Hydroxide, it's actually OH-. It's a polyatomic ion, the -1 charge. Nickel has a +2 charge. The way you would answer this is by using the crisscross method. This 2 gets written down here, and this 1 gets written over here. And your correct answer is nickel OH2. And that is it for today. That's actually it for the week. Bye, guys. I'll see you next week. Wait. Bye. Have a great week.